there, we're going to continue our discussion with the multiplying of complex numbers where we're going to look at some other examples. Just recall that there's three steps when multiplying complex numbers, and they follow the same basic rules as polynomials. You distribute the terms, simplify, then write your final answer in the term in the form a plus bi. Again, if you can, you should probably simplify before you begin these steps, just like with every single case. And then remember that the term conjugate refers to a complex number that's written in the form of a plus bi, and the conjugate would be a minus bi. All right, so here's the first question. Pause the video, work itself, and we'll go over it in a second. All right, so what we're going to do is distribute. Again, we're going to take the term, the 4 term in this left parentheses, distribute to the 4 and the 7i on the other side. Then we're going to take the minus 7i, distribute to the 4 and the 7i. So we get this. When we simplify, we end up getting 16 plus 28i minus 28i minus 49i squared. Remember that when you have an I squared like this, you drop it and switch the sign in front. So this is actually plus 49. 28i minus 28 actually cancels out, and you end up with 16 plus 49, which gets you 65. Now, part B says, what do you notice about these two binomials? So if we look back to the beginning, we have a 4 minus 7i, 4 plus 7i. They're exact numbers, but with the middle sign flipped. These are conjugates. So this is an example of a conjugate. And then the final answer is, what is the product? Is the product a real or imaginary number? Well, since there's no I term, this is a real number. And remember, that's the main thing with conjugates. When you have a conjugate multiplied by the original number, your final answer will not have an imaginary part. It will have just the base number. It will have a real answer. So it's definitely something to kind of keep an eye out for. Especially can help with some multiple choice questions, where if you realize that your numbers that you're multiplying are conjugates, you just get rid of any choice that has an I in it, because your final answer has to be a real number. Alright, here's the next step. Pause the video, work itself, and we'll go over in a second. Alright, so again, we distribute. So 6 times 4, 6 times minus 3i, 2i times 4, and 2i times minus 3i. This simplifies to 24 minus 18i plus 8i minus 6i squared. I squared is negative 1, so this becomes plus 6, and we can get rid of the I squared. So we combine the 24 plus 6 to get 30, the negative 18i plus 8 to get negative 10. So we get 30 minus 10i. Down here, same thing. Distribute the 3 times 7, 3 times 2i, 5i times 7, 5i times 2i. This becomes 21 plus 6i plus 35i plus 10i squared. The I squared drops out, and this flips the sign to be minus 10. So now my final answer, we have 21 minus 10, which is 11, and 6i plus 35i, which is 41i. Right, and that's your final answer. Here's the next step. Pause the video, work itself, and we'll go over in a second. Alright, so distribute the negative 2 times the 3 times the minus 2i. Distribute the 6i, 3 and minus 2i. This gets us minus 6 plus 4i plus 18i minus 12i squared. I squared drops out and turns into a plus 12. So minus 6 plus 12 is 6. 4i plus 18i is 22i. And that's your final answer. Here, our first step is actually to rewrite and simplify. Again, that's always going to be your first step. This can be rewritten as 9i. This is 3i. Then you once again distribute 3 to the 5, 3 to 3i, minus 9i to the 5, minus 9i to 3i. Combine, I squared drops, turns this into a plus 27. So 15 plus 27 is going to be 42. 9i minus 45i is minus 36i. That's your final answer. All right, two more questions. So here's the next one. Pause video, work stuff. I'll go over in a second. All right, so this one's a little bit weird at first, but what they basically want is they want you to take this term, the 3 plus 2i, and multiply it by the 2 minus I. And then to write the final answer is a plus bi. So that's what we're going to do. 3 plus 2i times 2 minus I. Again, distribute the 3 and the 2i. So 3 times 2, 3 times minus I. 2i times 2, 2i times minus I. To get this, that simplifies to 6 minus 3i plus 4i minus 2i squared. I squared drops, turns into a plus. So 6 plus 2 is 8. Minus 3i plus 4i is plus 1i. So we get 8 plus I. And this is the last question. Pause the video yourself. We'll go in a second. Alright, so this one's weird. Basically, it wants you, instead of using numbers, we're going to leave it in these variable terms. So we're going to leave the A and we're going to leave the B as is. And they want us to show that the final answer is a real number. Basically show that the I drops out. So we're going to start with this. A plus bi times a minus bi. We're going to do the same thing that we've done before. Distribute the a to each term. Distribute the bi to each term. So we end up getting a times a plus a times minus bi, bi times a, bi times minus bi. So 18 times a is a squared. A times minus bi is minus abi. This one's going to be plus abi. Remember, order when it comes to multiplication doesn't matter. Bi times a is the same as a times bi. And then bi times minus bi gets us minus b squared I squared. Remember, that's just like we did that with polynomial section, multiplying variables. A b times a b just gets us b squared. I times I gets us I squared. So we end up having this. Notice this is an ABI, this is an ABI. They end up canceling out since they have different signs. And then the I squared drops out, becomes a plus in front of the b. So we end up getting a squared plus b squared. So this shows that when you are multiplying a number by a complex number by its conjugate, not only does the I term drop out, but basically you can simplify the answer so that you just square the first term and square the second term. If you recall back to the previous example we had, we did this 4 plus 7i times 4 minus 7i. We can actually use this scenario, if you remembered it, to say, well, it's just going to be 4 squared, which is 16, plus 7 squared, which is 49. 16 plus 49 is 65, which if you go back in the video, you'll see that it was, in fact, 65. So it kind of helps give you a shortcut to dealing with these conjugates, but they're easy enough not to need it. All right, that's pretty much it for this. You'll end up having a quiz later on. So if you have any questions, feel free to let me know. Send me a message on mine. Otherwise, good luck and have a great day.